Hello, everybody. Thank you so much for coming here to listen to my talk. My name is Kennedy Tokura. I am the co-founder and CTO at Mitigant. Mitigant is a cloud security startup based in Germany. We are the first cloud native continuous security verification platform. So today I'm going to be talking about demystifying security chaos engineering. So let's get at it. So basically, for us to discuss security chaos engineering, we have to first go to the roots of we have to go to the roots of Netflix. We basically have to talk about Netflix for us to understand the origins of chaos engineering. So basically, we understand that about 10 years ago, while they were undergoing their transformation, journey, they actually wanted to have a better level of availability, and therefore they moved to Amazon Web Services. And so when they got Amazon Web Services, it wasn't long before they realized that virtual machines could actually just go offline without any warning. They could just go dead without any prior notice from Amazon, from AWS. And as you can imagine, this was a huge problem for them, and they tried to solve it in their own way. Eventually, they came up with this tool called Chaos Monkey. And the job of Chaos Monkey was pretty simple. Go to the production environments, take off virtual machines in order to simulate what might happen in real life, allow the engineers to be able to craft systems that can actually remain online regardless of these chaos that was being caused by Chaos Monkey. Now, this was very sounded to be very crazy at the onset, but eventually it became very useful for them because over time they realized that engineers adapted to this chaos that was being caused by Chaos Monkey, and their system became resilient. I mean, it was so successful that even when entire regions of AWS went offline, Netflix was essentially online, and their streaming services were not affected, and they were able to serve their customers. So essentially, that experiment, which sounded very crazy, became a success. Now, you might be wondering, so what is the connection between chaos engineering and the security chaos engineering? And I'm just going to go into that right away. All right. So what you see before the screen here is a cloud native attack surface. So the cloud native attack surface, as you see here, it's pretty complex, right? Here you can see an attacker. You can see lots of lines here in red, and you could see a lot of things that I'm going to explain in a minute. But these lines are attack paths which show the different approaches which an attacker can actually use to compromise all of these resources you see here. Now, this cloud native attack surface has been it is a concept actually was introduced by the Kubernetes security team called the forces of cloud native security, and this is the concept I'm using to illustrate what I term as the cloud native attack surface. So you got the code layer. So this attack surface is actually made of different abstraction layers. First is the code that it consists of source code, lambda functions, and stuff like that. The next is the container layer, which here you see things like Docker, Docker repositories or Docker registries, and Docker images and things like that. Then you have the Kubernetes cluster, which, as we know, is for orchestrating workloads, for coordinating and maintaining workloads of different kinds of complexities and capacities. And of course, the underlying layer is the cloud infrastructure itself. Here we are using, I'm using Amazon Web Services. And you could see here you have things like identity and access management, you have S3 buckets, you have databases. So this is very, very typical of what we refer to as cloud native infrastructure. And in the end, the cloud native attack surface demonstrates the different paths that are exposed to attackers, and which attackers could actually leverage to exploit a cloud native infrastructure. Now, the cool thing here is, oh, well, not the cool thing, but the thing here is that, for attackers, this entire thing you see here is just one thing. They do not look at these abstraction layers. The abstraction layers are not really, they are not really important for attackers. As defenders, this is really important to us because, for one, our level of understanding is sort of based on these abstraction layers. The way we deploy, the way we deploy, the infrastructure itself, the way we manage it, the way even our security tools are designed. They are implemented along the lines of these abstraction layers. Now, this creates a lot of problems. First, we have the way our security tools are designed. They are deployed in silos. These silos often do not talk to themselves. It means that if an attacker is able to move from one abstraction layer to the other, there's a high chance that even these tools are not even our security tools are unable to understand these kinds of attacks. So essentially, we have a lot of problems, and I will just look at three of these problems in a little bit more in details, or a little bit more. So the first is complexity. We have already looked at it. Abstraction layers introduce multiple layers of or different kinds of complexities, making it very difficult for us to even understand the kinds of threats that might be within this cloud native infrastructure. The other problem is dynamic security posture. What do I mean by this? Well, as a defender, you want to understand how you want to understand your security posture. But in a cloud native infrastructure, the infrastructure itself is dynamic. You're deploying every time, and it is becomes really, really complicated, or difficult at least, to understand at every point in time the risk and the threats that are in this infrastructure. Becomes really, really difficult to understand a grasp, or to get a grasp of the security posture per time. And this leads to the next problem, which is lack of resilience, right? So in these kinds of environments, you realize that the defensive, or let's say the protective systems themselves, are already lacking. They are not they are not very well suited to defend against attacks. And you have to really, really begin to think about layered security postures. You have to think about the defensive, or the detective systems, or the recovery systems, and you have to actually think about resilience. How do you not just protect, or prevent attacks? How do you actually detect attacks, and even continue to operate regardless of the kinds of attacks that you might be encountering per time? So resilience, lack of resilience, is a problem we have in our cloud native infrastructure. So how does security and chaos engineering come into play here? So basically, security chaos engineering is really, really, really about experimentation, security experimentation. We have just looked at a cloud native attack surface, and it is complex to understand where attackers might come in from. So it is cloud, the motive, or one of the motives of security chaos engineering, is basically that you want to be able to experiment, and you want to be able to craft hypotheses regarding regarding, you have to be creative about it. You have to think about what you think might go wrong, and you have to construct basically experiments which are security faults in themselves, that will test and validate your hypothesis. And this should help you to gain knowledge about that system. This should help you to discover blind spots that might be hidden in the system. And the next part of it is continuous learning. So continuous learning is all about you know what you do with this knowledge that you gain. You have to put it back into the system. You have to use it to harden the system. You have to continue doing this iteratively, so that eventually you have a system which you have a deep understanding of, and a system that you have continuously hardened, and a system that actually can proactively respond if there were attacks. So let's see more closely how this works. So I already talked about the hypothesis, how you are going to define hypothesis of security faults. After that is done, you got to inject these faults into a target system. And of course, this might be things like, Docker containers, or the cloud infrastructure itself. And then the next big thing here is you want to observe. You want to stay back after injecting the attacks. You want to observe how the system reacts to these security faults. And essentially, what you are trying to look at is you're trying to look at the different security controls that have been implemented in this target system. You want to see how they respond to their attacks. Maybe you might have preventive controls like identity and access management systems, or firewalls, or detective controls like intrusion detection systems. All of these tools are deployed for certain reasons, and you want to be able to see how they respond to these security faults that are being injected. And the next big thing there is, okay, how to respond, it's not enough. How do they impact on the attributes of security? How do they impact on your confidentiality? Do they violate any integrity concepts, or do they violate any availability expectations? In the end, you want to be able to really, really see how the attacks that you've injected impact upon these attributes. So clearly, let's look quickly at the advantages. So um, definitely, we expect that after you have been able to go through different phases of experimentation, you should be able to gain confidence in your cloud security posture, because after some time, you're able to see the kinds of attacks that you can survive, and you can actually understand the threats that are that are against your system, and you have that level of confidence. Of course, the next thing is you want to verify. Security Chaos Engineering helps you to verify your security return on investment. I mean, we all know here that security investments are really pricey, they're really expensive. And usually, a time comes when you actually want to justify whether these investments are actually coming back, if you are actually gaining from from these investments. Of course, the other advantage for security chaos engineering is realistic scenarios. What do I mean by realistic scenarios? Well, usually when you have your security engineers deployed, or working in a certain environment, you want to actually test how they perform under realistic situations. Whether there is an attack, you want to see whether they're able to quickly implement countermeasures, whether they're able to understand the steps, the playbooks that they have created, whether they're able to know how and when to use these playbooks, whether they're able to do things like analyze the logs and make use of the logs. All these kinds of evaluations, you cannot just get them. You need to inject real attacks that allow your security engineers to be able to perform, and that also helps you to understand how far they can go. All right, so this brings me to the end of my presentation. Thank you so much for coming here. Thank you for listening to me. I'm always ready to listen to, to answer questions. I'm really, really passionate about this topic. Feel free to reach out to me. And if you have any questions, you can send emails to me. You can reach me on LinkedIn or even Twitter. Thank you once again. Enjoy the rest of the conference. Bye.